Saya Fitri, saya Anggrek, saya Catur, saya Feni,
saya Bagas, saya Handayani, saya Dimas,
saya Dodi,
dan saya Fadillah. Kami akan menjelaskan tentang laju reaksi.
Selamat menyaksikan.
Menjelaskan tentang laju reaksi. Laju reaksi adalah
Jadi, laju menyatakan seberapa cepat atau seberapa lambat satu proses berlangsung. Laju juga menyatakan besarnya perubahan yang terjadi dalam satu satuan waktu. Jadi, satuan waktu itu dapat berupa detik, menit, jam, hari, ataupun tahun.
laju reaksi pun juga adalah perubahan konsentrasi reaksi atau reaktan atau konsentrasi hasil reaksi produk tiap satuan waktu.
Yang mempengaruhi ada 4, yaitu ada suhu, konsentrasi, katalisator, dan luas permukaan. Nah, di sini kita berdua bakal ngejelasin suhu dan konsentrasi. Nah, suhu merupakan ukuran kuantitatif terhadap temperatur panas dan dingin. Diukur dengan termometer. Suhu tidak dapat dilihat tetapi dapat dirasakan. Makin tinggi suhu suatu benda, maka makin tinggi derajat panas yang dimilikinya. Next, konsentrasi akan dijelaskan oleh Dan.
Baik, saya akan melanjutkan konsentrasi larutan. Konsentrasi larutan merupakan cara untuk menyatakan hubungan kuantitatif antara zat terlarut dan pelarut. Menyatakan konsentrasi larutan ada beberapa macam, diantaranya fraksi mol. Fraksi mol adalah perbandingan antara jumlah mol suatu komponen dengan jumlah mol seluruh komponen yang terdapat dalam larutan.
Selanjutnya, katalisator. Katalisator adalah zat-zat yang bekerja mempercepat suatu reaksi kimia tertentu tanpa katalisator itu sendiri mengalami perubahan yang permanen.
Selanjutnya, luas permukaan sentuh. Semakin besar luas permukaan sentuh partikelnya, maka frekuensinya tumbuhan bisa jadi semakin tinggi.
One of the most fundamental parts of usually an advanced chemistry course is to talk about kinetics, or the rates at which chemical reactions happen. There's a lot of math usually in this section, and the way in which we teach it usually involves a graphical analysis, sometimes a calculus derivative method. You can also use integrated rate laws. This is well beyond the scope of a general chemistry class, but the rate at which a chemical reaction happens, I think, is something that's important and fundamental to any chemistry class. Students should understand the factors that cause reactions to go faster and slower, and in our everyday lives, this is one of the things that we do. If you're noticing something isn't going fast enough, students usually know that you heat it up to make it go faster. So a nice elementary reaction that you can use to demonstrate what's happening with effects of reagent concentration and with temperature is to use the blue bottle reaction. What I have here are reactions that have already been prepared. I'll demonstrate them first, and I'll talk more about the chemistry in a little bit. But right now we have the same contents. We have some methylene blue, some potassium hydroxide, some dextrose, and just water in each one of these bottles. The same concentration of all solutes and all reagents is the same for every bottle. The only thing I've done different here, I have 4 different temperatures. One of them is at room temperature. I do one with cool water. Usually I just take the cold tap water out of my sink. I have this one on an ice water bath, and then this one is a warm water bath. Don't get this too hot. You can decompose the compounds very quickly and cause an unwanted side reaction. So this one's at about 37 Celsius. This is at 25 Celsius, this is at 15 Celsius, and this is at about 2 Celsius. So I'm going to pull all of these out of their solutions, knowing what temperature they're at. So we have about 2, 12, 25, and 38. So we've got about 10 to 12 degrees difference between each one. You can try to get exactly 10 degrees Celsius difference I've never been able to, so I don't bother. I just get high, low, and some middle ground temperatures when I do this in class. You can also see a little bit here, this is getting yellow, so it's starting to decompose a little bit. These don't last very long. Now, I do need a volunteer to help me out, so Peg is going to help me. In my classroom, usually have a student come in and we just practice shaking, so that, we'll do it without the flasks. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, so we get used to shaking it as similarly as we can. So ready?
How many?
Let's go for 10. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, one of the neat things about this reaction is right off the bat, you see a color change happening out of nothing. You just shook it. You didn't add any compounds, and all of a sudden you noticed a color change out of nowhere. That's a pretty brilliant thing for a student to see the first time. But then the next thing we start to look at, this one's already turned back. This one's starting to fade. And then on down the line, we get more and more fading over time. So what's happening here? In the hot flask, or the warmer flask, those particles have lots more kinetic energy than they have in the cold flask. So we can get lots more kinetic energy going around. These are bombarding into each other. More particles, when they collide, have enough energy to make that chemical reaction happen. So because we have more particle motion, the reaction goes more quickly. We have more energy available to make that reaction happen. Here we don't have quite as much energy, and here these are taking a very long time. This can take up to 10 minutes sometimes. And I usually, if this one gets really cold down to like 2 degrees, sometimes it never even changes. There's so much that's gone in here, and the molecules are moving so closely we're so close to a freezing point, the molecules are moving very slowly, that this one sometimes never even changes for me. So the students can get a very clear visual picture that higher temperature will allow for a higher reaction rate. So it's a really nice visual demonstration for something that kids can't usually get a good picture for. Now, this one's temperature. We can do the same thing with concentration of reagents. I mentioned that inside of these we have dextrose, we have potassium hydroxide, and the methylene blue is what you're seeing change color. That's changing color as part of this reaction. So we have different concentrations here. In one of these, I have the same mixture solution that I've always had. In one of them, I've added 3 extra pellets of potassium hydroxide, and in one of them, I added 6 extra pellets of potassium hydroxide. We're going to do the same thing, shake 10 times, and see what happens with the different concentration of potassium hydroxide in this reaction. Ready? And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So same thing, we get a blue color. And sometimes I'll use this at the beginning and I will tell my students which flask has which amount of potassium hydroxide in it. If I want to use this as more of an in-class assessment of whether they're catching on to what I'm talking about, sometimes I will just shake them and have them vote which one had the most potassium hydroxide, which one had a smaller amount of potassium hydroxide, and which one had no additional potassium hydroxide. So I can get a quick in-class assessment of what's going on. So we can see that this one changed first, this one changed second, and this one still has a pale blue color in it. So what's happening? The most potassium hydroxide was in my middle flask, the second most potassium hydroxide was in my side flask, and the most potassium hydroxide concentration was over here. And this one can be repeated several times, so if the kids aren't believing you on trials or you're worried somebody's shaking harder than the other, then you can explain based on what's happening with the amount of shaking, or shake it longer until the students are satisfied that the results are consistent, which is always a good thing for them to do. Now, to talk a little bit about what's happening here, you can also use this as a way to start talking about reaction mechanisms. Not all chemical reactions happen in one step, even though very often in a general chemistry course we just say reactants go to products, that's it. We don't say sometimes the reactant goes here and then here and then here and then becomes here and then it becomes product at the end. We're usually just worried about the net reaction. In kinetics, though, we're interested to see what steps, and if they ever go on to take organic chemistry, everything is about reaction mechanisms and what steps happen on the way to making products. So I'm going to go to the board and look a little bit at this reaction mechanism.
Dari video tersebut dapat kita ketahui bahwa pengujian tersebut melalui pengujian laju reaksi dengan perbedaan suhu antara A suhu dingin, B suhu ruang, C suhu hangat, dan D suhu panas. Bahan yang digunakan yaitu kalium hidroksida dan metilen blue. Dengan cara melakukan shake sebanyak 10 kali, dan yang diamati yaitu perubahan warna bolak-balik dari tidak berwarna ke biru dan sebaliknya. Dan selanjutnya akan dilanjutkan oleh Penny.
Pada sampel yang disediakan yaitu A, B, C, dan D, setelah dilakukan pengujian, setelah dilakukan pencekan sebanyak 10 kali, itu menunjukkan hasil perubahan dari yang paling cepat berubah warna, yaitu sampel B, D, C, dan A. Perubahannya dari tidak berwarna ke yang berwarna biru. Kemudian diamati lagi reaksi baliknya, dari yang paling cepat berubah dari yang tidak berwarna ke yang berwarna biru, yaitu D, C, B, dan A. Di mana kode D itu adalah suhu panas, C itu suhu hangat, dan B suhu ruang, dan A adalah suhu dingin.
Penyampaian tadi kita dapat mengetahui pengertian dari laju reaksi, faktor-faktor yang mempengaruhi laju reaksi, dan hasil pengamatan dari video yang tadi ditampilkan, di mana ada suhu dan konsentrasi yang merupakan faktor yang mempengaruhi percobaan laju reaksi. Selanjutnya Bagas.
Di mana pada konsentrasi, apabila konsentrasi semakin fungsi maka semakin cepat terjadinya perubahan reaksi. Dan pada suhu, apabila semakin panas maka akan semakin cepat laju reaksi yang berlangsung. Sekian.
Sekian dari kelompok 1. Bila ada salah mohon dimaafkan, dan bila ada rasa mohon diungkapkan. Wabillahi taufiq wal hidayah. Wassalamualaikum warahmatullahi wabarakatuh.